Okay, Miss V here, and we're going to start our dimensional analysis notes. So if you haven't already, go ahead, open up Classroom, find your 8 homework dimensional analysis notes. And this is mine on the left. Remember, yours is over here on the right that has your name on it. So click open your Cornell notes, and you can start taking notes. Okay, so make sure that's open before we begin, and let's get started. Okay, so we're going to talk about dimensional analysis, and the more common way you might hear them talk about is conversions. Okay, we're going to review a little bit about measurements as we go, but our essential question here is, what is dimensional analysis and what are the steps? We're going to talk about that. We're going to do one step, and we're going to actually expand this second semester. So if we remember, a measurement is a quantity that has both a number and a unit. When we talked about measurements, this is very, very important. It has to have a number and a unit. If you don't have the units, dimensional analysis is extremely hard, okay? And if remember, this is kind of a map of the metric system. It is absolutely crazy, but if you are really great at math, you can understand as you go up and down, you move the decimal point over 1. So as you go up or higher, like 10 to the 18th, you're going to move the decimal point to the left. The number is going to get smaller. And then as you move down, the decimal point will move to the right because the number will get bigger because the conversions are smaller. Okay. Same here. As we go up to the high ones, decimal point goes to the left, depending on how many zeros are there, especially the power there, or it goes to the right. If you're going into AP Chemistry, definitely you need to understand really well dimensional analysis because they go into this much more in depth and they're going to go farther than us. We're going to go to like the centa and the milli and maybe the kilo. They go even farther up, like 10 to the 18th, okay? So if you remember, I talked about the base units, what we use. Length is in meters, mass grams, temperature kelvins, time seconds, and volume liters. This is very important. This is in your measurements notes as well. Okay. And if you remember, mass is kilograms, and these are some conversions I gave you, and volume is in liters or milliliters. This is really important to be able to tell which is a mass, which is a volume. If you remember, mass is more like, and we'll talk more as we get into this unit, but mass is how much stuff is packed into something, and volume is how much space it takes up in the world. So we'll learn more about the difference between mass and volume as we go forward. These are some basic conversions that I gave you in the beginning, and this is in length and it's in centimeters, and I will always give these for you in a test, okay? So length is definitely meters, okay? In dimensional analysis, this is what it is. So dimensional analysis is just like conversions. If you guys can remember from probably your first semester of Math 1, you actually learn how to do this from like going from inches to feet, or maybe going from feet to miles. That is dimensional analysis, okay? And so here in chemistry, we do a lot of it, but we go between meters, grams, and liters, grams, and meters. I always get those confused. So you can see if we have meters here, and this is our main one, and we want to go to centimeters, we notice that it's going to the smaller one, so we would move it 2 spaces because centa, less like century, is 100. So that can help you. And if you're moving it down, then your decimal point goes to the right as well. And if you're going up to the higher ones, to the bigger numbers here, and it's kind of, you have to think about it. If we go to the left, those are our bigger numbers, and that's when we move the decimal point to the left. And if we move it to the right, we get to the smaller numbers, and that's why the number gets bigger. And I will also show you a way to do dimensional analysis if this is just not, this is not working, which is just fine, okay? But an example here is change 4.5 meters into centimeters. So your match of digits in your measurement, okay? So we have 4.5 centimeters here, and we want, or 4.5 meters, and we want to go to centimeters. So it's 100, so there's 2 zeros, so we're going to move that decimal, okay, from here 1 two spaces. There's 2 zeros. We'll move it 2 times to the right to get 450 centimeters. This is one way you can do it. If you can do it this way, more power to you. If you can't, I'm going to show you a different way. So it converts one unit into another unit by the use of conversion factors. So this is kind of a definition of what dimensional analysis is. And we will use units, cancel out units to change units. Okay, that's why it's very, very important to use units. I actually do dimensional analysis a lot. It really helps me. The decimal point sometimes just it doesn't click in my head, so I use this a lot. So this is a big thing. You put the units you want on the top and the units you have, and I'll explain this as we go. Okay, this is the units you want, units you have. So want on top, have on bottom. So if you can remember this, it'll really help you. So we want to see how many grams are in 1.2 milligrams. So we always start with our given. Okay, and just like in math, it's like a 1 is underneath here. Okay, so it's 1.2 milligrams, and we're going to multiply by our conversion. And our conversion is in every 1 gram, there's 1,000 milligrams. And I would give this to you. And the reason you see the milligrams on the bottom is because you're going to put the units you have on the bottom. So milligrams is what we're starting with. So milligrams will go on bottom. And the ones we want, it asks, and the question is grams, so grams will go on top. And 1 gram equals 1,000 milligrams. So then 1,000 goes with the milligrams and 1 goes with the grams. Okay, and you can see, that milligrams cancel out. Then you go ahead and read. Well, it's 1.2 times 1 divided by 1,000. Okay. Okay, one-step example. So let me see. So remember, we always have to start with the given. Okay. So how many milliliters are in 15.6 liters? And 1 liter equals 1,000 milliliters. So our given, we start here, is 15.6 liters. And remember, now we're going to do our conversion. So we're going to put the units we have on the bottom. So the units you have, which is liters. And you're going to put the units you want on the top, which is here. They asked you, which is milliliters. Now what you're going to do is you're just going to match up these numbers. So there is a 1 with the liter, okay, and there's 1,000 with the milliliters. So now you're set up. Then you also want to check and make sure your units cancel. So liters cancels liters, okay, not the numbers, just the units, and we are left with milliliters, which is what they're asking us for. Then we go ahead and we just read across, and it's 15.6. Anything on the top you're going to multiply it by, and anything on the bottom you will divide. So 15.6 times 1,000, okay, equals 15,600, and we're left with milliliters, okay. All right, let's look at another one. So how many grams are in 1.2 milligrams? And for every gram, 1 gram, there's 1,000 milligrams. So we start with our given, which is 1.2 milligrams. And now we're going to do our conversion. We're going to put the units you have on the bottom, which is milligrams. That's where we're starting here. And then you have the units you want on the top, which are grams. Then we're going to match up our numbers, okay? So with milligrams, there is 1,000 with it. And with grams, it's 1, okay? Now we're going to check our units. Milligrams cancels milligrams, only the units, not the numbers, and leaves us with grams, which is what we were asking for. Then we read across. Remember, anything on top we multiply by, anything on the bottom we divide. So then we'll do 1.2 divided by 1,000 times 1, which is doesn't do anything, which will get you 0.0012 grams. Okay. So this is a little practice. I want you guys to kind of pause the video right now. I want you guys to try it and practice it. So pause the video, write these in your notes and start working on them, then come back and you can check them. All right, hopefully you did stop and try them. This is probably one of the hardest concepts here in chemistry. And if you get this down as we use it, hopefully throughout the thing, you will have a bit easier time when we get to stoichiometry in the second semester. So you should have gotten 2.3 meters for number 1. Number 2 is 3,000 centimeters here. Number 1 over here is 0.0772 kilograms. And number 2 here is 64.7 grams. Okay, so now what I want you to do is go back and process your notes. You're going to go back, highlight important information, and underline vocabulary words or unknown words. Write down any connections you have with the notes in the left-hand column. Write a 2 to 3 sentence summary using the processing you did above. And then when completed with the summary, with the highlights, make sure all your titles are in, go ahead and turn in your notes, okay? And if you have any questions, just let me know.